Hello everyone, this is Chris back again with the Ancient Scholar. As promised, I'm going to be doing a series of videos on waves. So it's just a real basic concept of waves and some wave mechanics. Nothing real advanced, but just to give us a fundamental understanding of what waves are. And as we'll find out, it's actually very complicated, a bit more complicated than you initially think to explain what really is a wave. But it's the understanding of waves that really helps us explain a significant portion of the physical world. So let's just go ahead and start and try to define what a wave is. And most sources would say that a wave is a periodic disturbance in a medium or space. So first of all, we need to understand what a periodic disturbance is. And when I think of periodic, what I think of periodic is occurring at a regular interval. Now that may be a regular interval of time, something happening once every second, for example, boom, 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 every second, that's periodic. Or I could also refer to some sort of distance. Maybe something happens after I move a certain amount of distance. That would also be periodic. With waves, generally what's easier, at least for me, is to look at a wave as a time disturbance. It's periodic. It's a disturbance that occurs after a certain amount of time or within a certain interval of time. For example, maybe I have something happening every second, once a second, for example. That's how I look at a wave. Now we talk about it's a disturbance through some sort of medium. What do I mean by medium? Well, I mean some sort of matter. That I have this movement through matter, this periodic movement of disturbance through the matter. This matter could be a gas, like oxygen, nitrogen, helium, the air that we breathe. And an example of that would be a sound wave moving through, a sound disturbance moving through the atmosphere. It could be a liquid, such as water. And we know about sonar waves. We know about the tsunamis that occur after large earthquakes underwater. That is a wave. And we'll talk about what it means in certain contexts. It can also be solids, right? We know that sound can move through solids. Anybody listens to maybe when I was a little kid, we used to have train tracks near where I lived, and you'd listen on the steel track, and you'd feel it vibrating, hear this rumbling sound, and you knew that a train was coming, even though the train was a long ways away. But it was that sound that those waves were propagating. Well, propagate means to move. You'll often hear that term, propagate, move through the steel, the solid steel on the train tracks. I could also have waves move through the earth itself. For example, earthquakes. We know that the waves of energy move out from the epicenter of the earthquake, and they propagate through the Earth's crust itself. So certainly you can see there are lots of media that waves can travel through, and there are lots of different applications for waves. I'm going to try to keep it as general as I can for these discussions. Okay, waves can also propagate or move through space itself. For example, a wave of light. Well, light doesn't necessarily need a medium like water or steel or anything like that to move. Light can propagate through space itself. So lots of different applications here. Okay, so it's a periodic disturbance. It moves through some sort of media, or it can move through space itself. So let's go ahead and just talk about the basic characteristics of a wave. And the basic characteristics that I want to talk about today are going to include the speed of propagation, or movement. I'm going to use propagation because you'll commonly see that used. So the speed, the frequency, the wavelength, okay, the wavelength, and the amplitude. So these are the four fundamental characteristics of waves. And what I'm going to do here is I'm going to draw a little graph here. That guy isn't working too well today. Let's try this here. I'm going to go ahead and draw an X and a Y axis. This is my Y and this is my X. And then I'm going to go ahead and I'm going to draw a wave on there. Now, the y represents amplitude. Okay, and then x is going to represent, we'll say x represents time. So amplitude and time. So what is amplitude? Well, amplitude, the way I look at it is it's a maximum difference of the disturbed quantity. It's the maximum difference of the disturbed quantity. Whatever is being disturbed, maybe it's air, maybe it's water, maybe it's earth, maybe it's a solid. So let's just go ahead and draw a wave here, and I think everyone's probably pretty familiar with what waves look like. But let's just go ahead and describe some of these characteristics. So, the speed of propagation. Well, that's how fast this wave is moving. Now, once we put a direction to it, of course, then speed becomes velocity, because velocity is a vector quantity. But it's how fast it's moving, and let's say it's moving this way. Okay? So we've got that. We know that. Different speed of sound, speed of something in water, speed of something in a metal, the speed of light, for example. They all take on very well-defined speeds or velocities of propagation. Okay, we've got that. Let's talk about the amplitude. So when we talk about amplitude, it's the what I said about amplitude is the maximum difference of the disturbed quantity. So if I start at x, at my baseline here, we can say that that's zero disturbance, okay? No disturbance. And if I go from the baseline to the very top, that's the maximum amplitude. So that's what we call amplitude. Likewise, I can go from here down to the bottom, and that would be my maximum amplitude. It's going to be the same up or down, however you want to look at it, okay? So that is what we mean by amplitude. Frequency. What is frequency? Frequency, the way I look at it, is it's the number of complete disturbances. Okay, so this up, down is a disturbance, right? And basically what I look at, a complete disturbance, is I look at the very top of one wave. I'll put a dot here and I'll go to the very top of the next. And that is a complete disturbance. I start up, I go down, and I go back up. A complete disturbance. Whatever the distance is between those two disturbances is what's known as a wavelength, and you'll often see it denoted as this little upside down Y. That's called lambda, and that means wavelength. It's often measured in meters. Okay, so we've got the wavelength and the frequency. Again, the frequency is just the number of complete disturbances per a certain interval of time. Generally, we will go with the frequency. We will generally go off of time. And the basic unit of frequency is something known as the hertz, or Hz. And that is one disturbance, one complete disturbance per second. So 1 hertz equals 1 per second. 5 hertz would be equal to 5 per second. 10 hertz, 10 per second, and so on and so forth. So those are the 4 basic aspects of a wave. I'm going to go ahead and cut it off here, and then we'll start talking about a little more in-depth knowledge about waves proper. Thanks for hanging in there, guys. Take care.